You've mastered DC circuits, but flip on a wall outlet and you're dealing with something different. Alternating current, or AC. In DC, the voltage holds steady. In AC, it rises, falls, and reverses direction over and over. Here's the good news. For a series circuit with resistors, AC follows the same rules you already know. There's just one new idea to add. First, what makes AC different? Direct current is steady, a flat, unchanging line. Alternating current swings up to a peak, back down through zero, to a negative peak, and back. That shape is called a sine wave. It repeats that cycle over and over. The number of cycles each second is the frequency, measured in hertz. Wall power is 60 hertz. The time for one full cycle is the period. Period equals 1 divided by the frequency. At 60 hertz, one cycle takes about 1/60th of a second. Now, the sine wave swings all the way up to its peak value, but that peak only happens for an instant. The value that actually does the work is called the RMS value. RMS equals 0.707 times the peak. Why RMS? Because it's the DC equivalent. 120 volts RMS heats a resistor exactly like 120 volts of DC would. That's the key. Your meter reads RMS, and your math uses RMS. So Ohm's law still works. You just plug in RMS values. So here's the payoff. With resistors only, a series AC circuit behaves just like a series DC circuit. The resistances still add up. R total equals R1 plus R2, and so on. The current is still the same everywhere in the loop, and the voltage drops still add up to the source. E equals V1 plus V2. The only new rule, use RMS values for everything. That's it. Let's do one. Example 1. 120 volts RMS across two resistors in series, 20 ohms and 40 ohms. Add the resistances. R total equals 20 plus 40. That's 60 ohms. Total current, I equals E over R total. 120 over 60. That's 2 amps. Now the drops. V1 is 2 amps times 20 ohms, 40 volts. V2 is 2 amps times 40 ohms, 80 volts. And they add back to the source. 40 plus 80 is 120 volts. Just like DC. Example 2. Let's go the other way. From peak to RMS. A standard wall outlet actually peaks at about 170 volts. RMS equals 0.707 times 170, which is about 120 volts. So across a 60 ohm heater, the current is 120 over 60, 2 amps. Same Ohm's law, RMS values. Let's recap. AC is a sine wave. Count its cycles each second, and that's the frequency in hertz. Use the RMS value, 0.707 times the peak, and every series rule you learn carries straight over. In short, a resistive AC series circuit is just a DC series circuit solved in RMS values. Next time, we add a coil or a capacitor and something new appears called reactance. That's when AC really gets interesting. See you at the board.